Hi everyone, happy Thursday Algebra 1. Once again, I'm sorry I can't be there with you guys right now, but let's get started nevertheless on today's notes. I think that we'll be able to do this efficiently without me in the room, almost as if I was there. So let's get started. Please make sure you have 2.5 multiplying real numbers. Please pause the video if anyone doesn't have that, and otherwise, let's begin. So, the first question I present to you is to find the sum of the following numbers. And we have a row of 5s, a row of 3s, and a row of 2s. There are a lot of different ways we could approach this. One approach is adding 5 plus 5 plus 5 plus 5 plus 5, adding all of those 3's together, and then adding all of those 2's. But that can take a pretty long time. So here is another way. Let's write this as option 1. Option 1. Notice that I have a row of 1, 2, 3, 4, 5 5s. I have a row of 5 3s, and a row of 5 2s. So, let's add those together. I know that I have 5 5s. I've got 5 3s, and got 5 2s. And I'm multiplying each of those because I have 5 of each of them. So now we have 5 times 5 plus 5 times 3 plus 5 times 2. Let's try to reduce or simplify this now. So 5 times 5, that becomes 25. Notice that we're doing the multiplication first because of PEMDAS. Adding that to 5 times 3, that becomes 15. And that last piece of multiplication here, 5 times 2 is 10. So now we have 25 plus 15 plus 10. All in all, that should give us, let's see, 25 plus 15, that is going to be 40, plus 10 is going to be 50 as our final answer. So that's option 1. We looked at each of those rows and we saw how many of each number was in those rows, and then used multiplication in order to find that sum. Another way is we could have looked at the columns. So let's see. Instead of looking at it horizontally, looking at it vertically, I've got 5, 3, and 2. Let's see, I've got 1, 2, 3, 4. I've got 5 columns of 5 3's and 2's, each of them in it. Another way to represent that, here's option 2, is we have 5 of these columns that have 5, 3, and a 2 in them. AKA, each column is actually worth 8. 5 plus 3 plus 2, nope, it's worth 10. 5 plus 3 plus 2, each of these columns is really just saying 10. If we do 5 times 10, we do get 50. So, whether you added up each of these individual terms, whether you looked at it through the rows or you looked at it through the columns, we got the same answer. Where is this leading us to? This is leading us to the relationship between multiplication and addition. So in our notes, it says multiplication is blank. Multiplication is repeated addition. For example, we can rewrite -2 plus -2 plus -2 as, well, I've got 3 -2's being added together. 3 times -2. Great. That's what multiplication is. So let's move on. Down here, example 1, let's multiply integers with different signs. So find each product. For this entire lesson, actually for all of today, we are not going to use our calculators. So if you have a calculator out, please put it away. We are going to rely just on our mental math. If you need a multiplication table, the substitute has multiplication tables to hand out to each of your pods. So just ask for that if you need it. But find each product. We have 8 times -4. If we did put that in our calculators, it would be -32. -9 times 11. Well, if we pretended that this was just +9 times 11, we would get 99. But because it's a negative, -99. We're going to go over why we have these negative signs here in 3 sections. So hold on if you're wondering that. 6 times -12. Ooh, should be, let's see, I'm going to do that one up here. So a 6 times -12, I'm just doing it as if it was a +12. 6 times 2 is 12, so I'll carry that 1. 6 times 1 is 6, plus 1 is 7. So, -72. -7 times 8. That should be -56. And -18 times 0. Well, anything times 0 is 0. Okay. Next up it asks, what is the sign of the product of 2 negative integers? Use this pattern to find -5 times -2. So let's fill this out. If we have -5 times +2, that is just going to be -10. The rule that we're going to find out later is when you multiply a negative number by a positive number, you get a negative number. -5 times +1, -5. -5 times 0, as we saw it before, anything times 0 gives us 0. And -5 times -1, this is where the pattern changes. This is actually +5. You might have learned in middle school that 2 negatives being multiplied together makes a positive. That is still true in high school. So -5 times -2, that is going to be +10. Because multiplying 2 negatives together makes a positive. With that rule in mind, try out example 2 on your own. So whoever is manning the computer, please pause it for about a minute and a half and let everyone try examples A, B, C, D, and E on their own. Okay, please look up and check your answer. You should have 36, 21, 105, 96, and 70. Notice that sometimes, like in example B, we have parentheses around both of these terms. And in example A, we have parentheses around just one of the terms. And in example D, we have no parentheses. Ooh, I can't write with the highlighter. No parentheses. In this case, it doesn't matter. When we are just multiplying terms out and there is only multiplication happening, it doesn't matter if there are parentheses around one of the terms, neither of the terms, or both of the terms. So let's write that as a note, maybe in the space up here. When there's only multiplication let's say you can use either the multiplication sign or the parentheses signs to indicate multiplication. Either one will do, and it won't matter. Note, however, that this is going to change when there's things other than multiplication in what we're working with, which we're going to see pretty darn soon. But before we get there, next prompt. In your own words, describe how to tell the sign of the product of two integers. And the sign, that just means, sign means if something is positive or negative. So I'm going to write if positive or negative. That's what the sign means. So if the two integers have different signs, then the product is negative. This is just like what we saw up in example number 1 in all of the examples highlighted in green with a positive and a negative number. But if the two integers have the same signs in the product, then the product is positive. Examples, well, we have, what was this, 5 examples up here in example 2. Those are 5 examples of two integers having the same sign and the product being positive. Another one is if we have like 2 times 2, both of those numbers are positive. 2 times 2 is positive 4. We got another positive integer as the product. Okay, I think we should feel pretty good about that. This is pretty much some review from middle school. So turn that page. And now we're going to generalize. When we have more than just two things being multiplied together, what's going to happen? So if you do have a calculator out, please look at this table right here and fill in the values of this column highlighted in green now. And keep in mind that instead of writing like parentheses, -2, parentheses, -2, parentheses, aka this guy right here, that's the same as typing in -2 times -2. Because we only have multiplication, it's okay just to use the multiplication symbol instead of parentheses. So please take a second, please pause this video, and I'll see you once everyone has finished the table. Okay, you should have finished the table by now, and I actually color-coded mine. You didn't need to, but you'll see why I did in a second. So I have -2, +4, -8, 16, -32, and 64. Now, our next question is, how many -2's are being multiplied together in each row? Well, it looks like this first one, we just had one -2 being multiplied together. Second row, we had 2 of them. Third row, we had 3 -2's. Fourth row, 4. Fifth row, 5. Sixth row, 6. Now, let's notice. What patterns do you see? I mean, I see that for all of these even numbers here, 2, 4, and 6, not only are all of these answers blue, but they're all positive. And for all the odd numbers, when we had an odd number of -2's being multiplied together, all of our answers were negative. So, let's generalize this. Multiplying an odd number of negatives, then our product is negative. Likewise, multiplying an even number of negatives the product is positive. And we can actually see this in our previous examples. Let's see. The bottom of page 1, if two integers have different signs, that means that if one of them is positive and one of them is negative, aka we only have one negative being multiplied together, then our product is negative. So we're checking out with our previous rule. These are the rules that we're going to need to know by heart as we move on in this year and throughout your entire math journey here at North. And if you continue any math classes at college, if you need to take an econ class or want to do something with that, you will need to know these by heart. So star these if you need. I'm going to put these little brackets around it. Okay. Next up, let's put this to practice. Example number 3, multiply real numbers. So it says to find each product. We know our rules on multiplying an odd number of negative numbers, we get a negative product. Multiplying an even number of negatives, we get a positive product. Try out A, B, and C. Once you've tried it out, please unpause this video and we will go over what we got. So, pause and go ahead. Okay, example A, using PEMDAS, we've got all multiplication. Let's go from left to right. So, multiplying negative 3 and negative 4, we get a positive 12, and then still times that 5. A positive 12 because we had two negative numbers being multiplied together, we get a positive. Now 12 times 5, we should get 60. Awesome. Next up, B. We have negative 9 times negative 5 times negative 2. So start this off, go nice and slow, start left to right. What is negative 9 times negative 5? Got two negatives being multiplied together, gives us a positive 45 multiplied by negative 2. And 45 times negative 2, let's see, well 45 times 2 is 90. We've got one positive number and one negative number being multiplied together, so that makes negative 90. Okay, part C. Ooh, I love this one. Okay. Let's see, we've got what, three negative numbers being multiplied together. So already looking at it, I see one negative, I see a second negative, a third negative. I know that our final answer is going to be negative because we've got an odd number of negatives. Going left to right, negative 1/3 times negative 3. Well, let's see, 1/3 of 3 is 1. And negative 1/3 times negative 3 will still give us that positive 1. Two negatives times the negative makes a positive. 1 times negative 2, that's just going to give us negative 2. And look, what I predicted before, because hey, I had three negative numbers, I predicted my answer should be negative. It was correct. Last one, D. Oh, this is a funny one. So if you plug this into your calculator, you might get the wrong answer depending on how you plugged it in. So let's try expanding this first. And you might not typically know to do this, but I'm telling you for now. Negative 3 to the 4th power, so exponents are the same as multiplying that many times. So that's negative 3 times negative 3 times negative 3 times negative 3. And let's do this left to right. Negative 3 times negative 3 is positive 9. times negative 3 times negative 3. Positive 9 times negative 3. So you've got a positive number times a negative number. So negative 27 times negative 3. When we multiply these ones, we get positive 81. So the next question asks, are parentheses negative 3 to the fourth power and negative 3 to the fourth power the same? Why or why not? Well, we just showed parentheses negative 3 to the fourth power is positive 81. So let's write that down. We said negative 3 to the fourth power is the same as negative 3, negative 3 times negative 3 times negative 3 times negative 3. And that reduces to 81. Awesome. Next, okay, negative 3 to the fourth power, using PEMDAS, exponents come before multiplication and division. In this case, this negative sign, because there aren't any parentheses, this is really saying negative 1 times 3 to the fourth power. Yeah, you might not have seen this before. This might be new, so pay close attention here. So negative 1 times 3 to the fourth power, because exponents come before multiplication, we're going to evaluate 3 to the fourth power first. So let's rewrite this, expanding out that exponent, negative 1 times 3 times 3 times 3 times 3. Okay. 3 times 3 times 2 times 3. Well, let's do this left to right. Negative 1 times 3 is negative 3 times 3 times 3 times 3. If we keep going, negative 9 times 3 times 3. We're going to keep going, and just to save us some time, we're going to get negative 81, which is different than positive 81. So, are parentheses negative 3 and parentheses to the fourth and negative 3 to the fourth the same? No. Why not? Because that negative sign is included in the multiplication of all of those 3's on the left-hand side, and on the right-hand side, it was just the negative 1 times all of that multiplication. So in your calculator, if you do want to calculate either of these two expressions, you have to put in parentheses or explicitly not put in parentheses so you get the answer that you want. So next page, turn that page. Are negative 4 squared and negative 4 squared the same? Why or why not? Take 1 minute and prove why these are the same or not the same. So starting now, please pause this video. Okay, here's the solution. Take a look. And let's not dwell on this one too long. Just like we had properties of real numbers for addition, we also have them for multiplication. And most of them actually have the same name because they look very similar to what we saw before. So the commutative property is seen as A times B is equal to B times A. Once again, as a helpful hint, I think of commutative, I think of a commute, going to school and from school. It goes both ways. It's like, a mirror. You can mirror these things and you get the same thing. So for example, 3 times 2 is the same as 2 times 3. The associative property, once again, to associate with someone means to be in their circle, to be in their group. So I think of grouping, which signals parentheses. And here, multiplying A and B first and then C is the same as saying A times multiplying B and C first. I'll have you guys come up with an example for that one. Before we do that, the multiplicative identity, A times 1 is equal to 1 times A, which is equal to A, aka multiply anything by 1, you get the same thing. I think I said this before, identity. This is me. Multiply me by 1, I'm still me. Okay, there aren't really any helpful hints I have for the second two properties. So, up next, come up with some examples for each of these properties. Try to do it on your own. Don't need to talk to anyone. Come up with some examples. Please pause. Okay, I filled in my own examples. So as long as you got something similar, we're on the same page. You don't need to have my exact examples. I used pi for these bottom two rows just because pi is a number. It follows these properties just like the regular numbers that we're used to seeing. Okay, we are almost done with our notes. Let's see, 26 minutes, doing pretty well. So, products with variable factors simplify the expression. What's happening now is instead of having just numbers, I'm introducing some variables, but we're still going to follow those same rules. Mr. Smith, what are those rules? They're exactly what we said before. Let's scroll down. If two integers have different signs, then the product is negative. If two integers have the same signs, the product is positive, which itself is encapsulated in this idea of multiplying an odd number of negatives, you get a negative product. Multiplying an even number of negatives, the product is positive. So, let's introduce some variables to this. If we have 8 times negative n, now we don't know the value of n, like if we're going to plug in 1 for n, if we're going to plug in pi for n, or negative a million, but right now it looks like the value of n as it stands is negative. So 8 times negative n, we've got different signs here, so the product is going to be negative. Let's try this next one. Negative 6 times y times negative y. Two different approaches with this one. One way is to go left to right because we just have multiplication. So negative 6 times y gives us negative 6y, and that times negative y gives us a positive 6y squared. Because y times y is y squared. Okay. Let's do C. 4 times, in parentheses, negative x to the third. And we worked with these parentheses before, so let's expand this out, see what we get. That's 4 times negative x times itself 3 times. At this point, you can go left to right, and I'm going to do that right now. Then I'm going to show you my little shortcut way. So 4 times negative x is negative 4x times negative x times negative x. Negative 4x times negative x is positive 4x squared times negative x. 4x squared times negative x gives us negative 4x cubed. So that's one way of doing it. If you'd like to shorten up the amount of time that you're writing, then after I expanded it out to this step here, I might notice, hey, I've got 3 negative x's being multiplied together. I know that if this was just positive x, we would get an x cubed. And, 4 is 4. But we have 3 negative x's, so an odd number of negatives. So this is really negative x cubed. So 4 times negative x cubed, I'd automatically think to myself, that's negative 4x cubed. So 2 different ways. You can go at it line by line, multiplying each individual thing together. You can do that. Or look at the bigger picture. How many negatives do we have being multiplied together? Is it even or odd? And go from there. I'm going to do that ladder method for this last one. So I have 2 times, and I have 4 of these negative f's being multiplied together. So 2 times, and I know I have 4 negatives being multiplied together. 4 is an even number. The end result is going to be positive. And f times f times f times f is f to the 4th. So 2 times f to the 4th, we're left with 2f to the 4th. Either way works. 1 saves time. 1 is a bit more algorithmic and make sure that you have the right answer. Okay. Example 5. Evaluate a variable expression. Evaluate the expression when x is equal to -2. Show all work. Alright, I think you guys can do this on your own. You can do A on your own. So don't even pause this video. Start A on your own, and I will start speaking when I think it's time. Okay, for A, we should have gotten -36. B and C are going to be a little bit trickier. Let's start with B. So we're plugging in a -2 into here. So 3 times in parentheses -2 cubed. So that's 3 times, then -2. That's the same as -1 times -2, which is just a +2, all cubed. 3 times a +2 all cubed, that gives us 3 times 8, because by order of operations, exponents first, which gives us 24. Gorgeous. Gorgeous, gorgeous. Last but not least, C. This one is going to require a note at the end. Let's plug in -2 here, so 7 times -2 in parentheses squared times -5. This requires a huge note at the bottom of your page. So draw a big star, just like I'm doing, and let's say that substituting values into exponents, we have to use parentheses. So let's write that. Substituting into exponents, use parentheses. So in this case, we didn't just say -2 all squared, because we know that that's different than with parentheses. We plugged it in with the parentheses. That's just a math rule we got to know. We're going to go from there. So 7 times -2 times -2, because that's what that squared means, times -5. -2 times -2 is a +4 times -5. So we get 28 times -5, which should give us -140. Keen beans. Okay. Last problem, example number 6. A helicopter is descending at a velocity of -15 feet per second. Find the displacement of the helicopter after 4.5 seconds. And we're given an equation that displacement is equal to velocity times time. So displacement, that's what we want. I'll highlight that in yellow, is equal to velocity, highlight that in green. Looking back at our sentence, a helicopter is descending at a velocity of negative 15 feet per second. So that is going to be our velocity. Find the displacement of the helicopter after 4.5 seconds. That will be our time. So now let's just plug things in. So displacement is equal to velocity times time. So displacement is equal to negative 15 times 4.5. And that's going to give us negative... I should have used units. Let's erase, folks. So sorry. It's been a long day. Let's see. Displacement is equal to negative 15 feet, and then per second. So I'm going to put that per second. That per is just saying, put that second on the denominator. Negative 15 feet divided by seconds. That's really what that per means. Times 4.5 seconds. And like we learned in chapter 1, the seconds over seconds is going to cancel out because you've got 1 in the numerator. Really this is 4.5 seconds over 1 over 1 in the denominator, so they cancel out. We're just left with negative 15 feet times 4.5, which should give us, it should be negative, let's see, 15 times 4 is 60, and then 15 times 0.5 is 7.5, so negative 67.5 feet. I think that's right. Great. And then we've got our note there at the bottom. So this wraps up multiplying real numbers. The big takeaways, pretend I'm holding up fingers. Takeaway number 1, multiplying an even number of negative numbers will give you a positive. Takeaway number 2, multiplying an odd number will give you a negative. In the same vein, if two numbers are being multiplied together and they have opposite signs, you'll get a negative product. Same signs, you'll get a positive product. And last but not least, this final note, substituting numbers into an exponential expression, use your parentheses. Put parentheses around what number you are substituting in, and you will be correct. All right, what's going to happen now is the substitute will give you the worksheet to work on to practice these multiplication skills. Really, we have to drill these in. It might seem like a burden going through all of these problems and maybe not getting a squishy ball for doing them. Sorry, Alex. But we need to drill these in to get these into our brains. By physically doing these over and over and over and over and over again, we become stronger and they are drilled into our brains even more. So the substitute will let you know which problems to do after you have completed those problems, probably at some point during third period. He will collect those sheets and we will move on to the second part of this packet, which is dividing real numbers. We won't get to the whole thing, but we'll touch a little bit on it. So by tomorrow we have a little bit of an understanding. So please work on those worksheets and then pause this video while you're doing that. When you're ready, you can unpause and we will move on to the second section of the notes. So, go to, please be productive. See you later. All right, welcome back. Now we are focusing on the second half of this packet, dividing real numbers. So please make sure that everyone has their notes out, turn to this page and they're ready to go. When they're ready to go, press unpause and we will start. So, we're going to start off with a definition. Two numbers whose product is equal to 1 are called reciprocals. That's R-E-C-I-P-R-O-C-A-L-S. P-R-O-C-A-L-S. Reciprocals. For example, 2/3 and 3/2 are reciprocal because, let's see, 2/3 times 3/2. We'll look at the numerator and the denominator. The 2 3s are going to cancel. The 2's are going to cancel. All that we're left with is 1/1, because when you cancel things out, left with the 1, we just get 1. So the reciprocals because they multiply to 1. And let's write that in English too. Because they multiply to 1. Okay. So to find the reciprocal of numbers, honestly, it's not that difficult. Take the number, keep the fraction sign, and flip what you see on the top and bottom. So instead of 11 or 6/11ths, it's 11/6. Bam. That easy. So -1/5, keep that fraction sign. Oh, and that negative sign. Let's see, 1/5, flip the top and bottom, we get -5/1. But in this case, we're not done yet. Anything divided by 1, just like anything multiplied by 1, you get itself. So instead of saying this, you should really just say -5. Let's use that knowledge for C. We have 34, but we don't have a fraction sign, so we don't really have anything to flip right now. Well, 34 is the same as 34/1. And now we've got something to flip. Keep that fraction sign, flip that top and bottom, the numerator and denominator, and you have your reciprocal. D. Let's see, -7. Once again, I don't see a fraction sign. So -7 is the same thing as -7/1. And now, keep that fraction sign. Flip the top and bottom. We've got 1/-7. We'll go more into this later, but this is the same as saying -1/7. That negative sign can come out to the front since it's only at the bottom. Don't worry too much about that one. But last but not least, 4/2. If you're thinking, okay, I'm just going to keep, that fraction sign, flip the top and bottom, so we get 4/2. No! That is not correct. Because 4/2 times 4/7 does not equal to 1. And our definition of reciprocals are those two numbers whose product is equal to 1. And it just so happened that flipping them before worked. So for 4/2, what we have to do first is turn this into an improper fraction. And we're going to need some space to do that. I didn't give us very, very much space. You guys stay on this page. I'm going to use this space right here, but please copy it down on your own page. So we've got 4/2. Let's rewrite this as an improper fraction. So this is the same thing as saying 4 plus 2/7. And still can't add these, so let's make that 4 a fraction. This is the same thing as saying 4/1 plus 2/7. But to add two fractions, we need common denominators. Need common denominators. So, 4/1, let's see, we want a denominator. Let's multiply 4 over 1 by 7 over 7, which gives us 28 over 7 plus 2/7. Now we've got common denominators, yay. We are happy. So we'll add those numerators and get 30 over 7. Although when you're using recipes for cooking and throughout middle school, you might have preferred using mixed numbers, throughout high school math, improper fractions are our friend. Improper fractions are going to be more beneficial to us and more useful. So get ready to use them a lot. So instead of writing 4 2/7, this is the same thing as 30 over 7. So to find that reciprocal, let's just flip it now. 7/30. Okay, so we know how to find the reciprocals of two numbers. This is going to be important when we're dividing. Division rule. To divide a number, A, by a non-zero number, B, multiply A by the reciprocal of B. Let's highlight that, or underline it if you've got a pencil. To divide a number A by a non-zero number B, multiply A by the reciprocal of B. And that is the key, multiplying by the reciprocal. The result is the quotient of A and B. Or as my teacher likes to sing, I don't know how to sing this, but leave it, change it, flip it, multiply them. Or leave, change, flip. Now the signs of the quotient of two numbers follows the same rule. That should say rule. Let's add that in. Follows the same rules, plural, as multiplication. Divide two numbers with the same sign. So the same sign, the quotient is positive. Divide two numbers with different signs, and the quotient is negative. We get a negative end result. Okay. We just learned two things. One, all about those signs. Two, to divide, multiply by the reciprocal. So, let's do some examples. Example A, find the quotient of 15 divided by a negative 5. So, our rules to divide are to leave, or you might call it keep. I like keep. Keep, change, flip. We are going to keep that 15, that first number. We're going to change that division into multiplication. And we're going to flip that last term. Negative 5, though, we can't currently flip it. Well, negative 5 is the same thing as negative 5 divided by 1. Now we can flip it. So negative 5 divided by 1, flip that, that's negative 1/5. So now we've got 15 times negative 5. I know that 5 goes into 15 3 times. And we've got a positive number times a negative number. So we get negative 3. Okay. Let's try that next one. Negative 45 divided by 5/6. Actually, I think you guys can do B and C on your own. Once you finish B and C, unpause this video and check your work. Okay. Take a second and check your work. Please feel free to pause this video so students can see if they got these answers. If you didn't get negative 54 and 0, please pause this video, chat with your teammates, with your mentors, and figure out why, what happened. Okay, so if you're ready to move on, last but not least, this is our final problem. I think it'll be our final problem. Yeah, it's going to be our final problem. Our final problem of notes. Negative 26 divided by negative 4 and 1/3. Here, I already see we've got a mixed number. Yikes. First step is going to be to turn into an improper fraction. Sorry, that's so messy. That says turn into improper fraction. Wow, that could not be messier. Okay, so negative 4 and 1/3. I'm going to take up some more space on the next page. Please feel free to do that work there. Your handwriting is a lot smaller. Negative 4 and 1/3. That's the same as saying negative 4 plus 1/3. And I see two different numbers here. One of them is a fraction, and we want to add it to the other. So let's turn negative 4 into a fraction just by drawing that 1 on the denominator. So now I've got negative 4 over 1 plus 1 over 3, but we need a common denominator. Need that CD. So let's multiply negative 4 over 1 by 3 over 3. So we get negative 12 over 3 plus 1 over 3. We've got that same common denominator. So we've got negative 12 plus 1 all over 3, negative 11/3. Whew, and that was just changing it into an improper fraction. That wasn't even the actual problem. Oh my god. So, we've got negative 26 divided by whatever I just said, negative 11/3. Negative 11/3. Did I do this right? Oh geez, I did this wrong. You know what? Okay, bear with me folks. Erase this word. So sorry. I wish I could go back and undo this, but it's a video. I'm going to scroll back down. This isn't negative 11/3. This should be divided by negative 13/3. Why is that? Let's go back. So I originally said negative 4 and 1/3 is the same as negative 4 plus 1/3. But let's look at our number line. Here's 0, negative 1, negative 2, negative 3, negative 4, negative 5. So negative 4/3, that means starting at negative 4, we're going to go 1/3 more into the negatives, right? We are more than 4, but we're into the negative, so more to the left. So maybe around there is where our point would be. What I wrote here in red now, negative 4 plus 1/3, that means starting at negative 4 and then adding 1/3, so going to the right 1/3. These are different. How should I change negative 4 plus 1/3 to make it match what we originally drew on the number line? We really want to start at negative 4 and go to the left 1/3. So, instead of plus 1/3, we want to subtract 1/3. Okay, so now negative 4 minus 1/3, we're going to go through that same process of finding that common denominator. I'm going to go through this a little bit quickly just to save us some time. So negative 12/3 minus 1/3 gives us negative 13/3. Okay, so this is the proper form. So going back to what we had before, let's see, negative 26 divided by negative 13 divided by 3. So, rules for division is to keep, change, flip. So, negative 26, keep that, change the division to multiplication, negative 3 over 13. For now, it doesn't matter where that negative sign floats with on that second fraction, as long as it's with only one of those numbers, either the 3 or the 13, doesn't matter which one. So negative 26 times negative 3 over 13, 26, or 13 goes into 26 2 times, that leaves 2 left over, times negative 3. Negative 2 times negative 3 gives us positive 6. Ah, yay! And that is our answer. Okay, we will finish the rest of these notes, pages 5 and 6, tomorrow. But for now, the major takeaways for dividing integers, or dividing real numbers, is 1, don't forget to keep, change, flip. 2, reciprocals. A reciprocal is a number that you multiply to another number to make it equal 1, aka, if it's a fraction, just the flip of that fraction. And last rule is division follows those same sign rules as multiplication. So divide two numbers with the same sign, the quotient is positive. Dividing two numbers with different signs, you get a negative. All right. So the substitute will now hand out your last worksheet of the day. Please work on this independently. Mentors, you will probably have a key, and I will see you all tomorrow. You will turn this one in as well. This will be for a grade, so make sure to complete this thoroughly. If you do not complete it all the way, then you will finish it for homework. Unless there are extenuating circumstances, in which case I timed this terribly and no one was able to finish this entire worksheet, then I obviously will not fail everyone. We'll talk tomorrow. Have a great Thursday, folks. See you tomorrow.